Hey guys, welcome back. This is Mr. Ray, and we're going to be solving triangles using SOH CAh TOA. Part 2, second part. Now take a look at this triangle, okay? When you have an angle, you have a hypotenuse, an opposite, and adjacent. The hypotenuse is always the diagonal. The adjacent is going to be the side that's going to be run along the angle. The angle is always between adjacent and hypotenuse, and the opposite is going to be opposite the angle, okay? Now, let's take a look at some problems, but first, we need to know what sine of an angle is. Sine of an angle, remember, SOH, right? Because what we want to realize is that we have an H, we have an A, and we have an O, right? So SOH, that means that's going to be opposite over the hypotenuse. And I'm not going to spell this out. This is the one time I'm going to spell all this out, okay? Opposite over hypotenuse, you can say O over H, okay? Now, what is cosine of the angle? The cosine of the angle is CAh. C-A-H. What does that mean? That means adjacent over the same side, the hypotenuse. That's how we get A over H. So CAh, and we get tangent of the angle, is equal to opposite over adjacent, O over A. SOH CAh TOA, that's where it comes from. Again, SOH CAh TOA. Let me give you an example. So we have a right triangle. Let's go ahead and label the sides. Well, this is always the H, the diagonal. And then the A is going to be here in reference to this angle theta here. Where's the O? The O is the opposite, okay? Now we can find all the relationships of that angle. What I mean is this: sine of that angle there, okay, that angle there is going to be what? It's going to be opposite over hypotenuse, okay? What is cosine of that angle? It's going to be adjacent over hypotenuse. What's tangent of that angle? It's going to be opposite over adjacent, okay? Because we just found out that that's the H, the 10 is the H, the 8 is the A, and the 6 is the O. For this triangle, which is very common, you could have these. And actually, if you heard about that before, that's a 3, 4, 5 triangle, okay? 3, 4, 5 triangle. Now, let's get to some specific problems. Okay, here's our first example. A right triangle has an angle of 38 degrees. It has a hypotenuse. The hypotenuse is 14. Find the opposite side x. Let's go through all of this step by step. This is a little bit more difficult than my previous video. If you need to watch that to get the basics of SOH CAh TOA, go ahead and watch that because this is part 2. But what do we know? Well, first we got to draw a triangle, right? Boom, we've got a triangle. Next, we want to label that we have a right triangle with a little square right here. Okay, now, what do we know? We have a right triangle has an angle of 38. Let's go ahead and put 38 here. You can put it here, or you could have put it there, okay? Now, if that's the case, this side is H, this side is A, and this side is O. We know that the hypotenuse is 14. And we want to find O, the opposite, right? We want to find O. The O is X, okay? Good. So we have this triangle with 14, X, A, and 38. If we're looking at O and H, we want to use sine, SOH CAh TOA. So sine of 38 is equal to the opposite, we don't know, that's X, divided by the hypotenuse, 14. Great. You're going to have to get out your calculator. So we're going to have 14 times sine of 38 degrees is equal to X. Make sure your calculator is in degree mode, not radian mode. And you get out your calculator and you do that. If you have any calculator problems, let me know. X is about 8.62. 8.62. Great, let's take a look at another problem. Okay, next problem. A right triangle has an angle of 52 degrees. The opposite is 11. Find the adjacent side x. First, we need to draw a triangle. Okay, we have our triangle, and it's a 90-degree triangle, right? Where am I going to put 52 degrees? Well, I would put it the way this triangle looks right here, because that's the bigger angle, okay? Because the opposite is larger, okay? Now, let's go ahead and label what we know. We know this is H. We know this is O, according to that angle, and this must be A, okay? What do we need to find? We need to find A. A is equal to X. Okay, what do we know? Well, we know that O is 11. O is equal to 11, okay? So we're looking at O and A. O and A. Which one, sine, cosine, or tangent, has O and A? That's right, tangent. So tangent of the angle is equal to O over A. Okay? If we're dealing with O and A, it's tangent. If we're dealing with H and A, it's cosine. If we're dealing with H and O, it's sine. Okay? Now, this is a little bit trickier. You're going to multiply both sides by x. So you're going to get x tangent of 52 degrees is equal to 11. Then you're going to take that 11 and simply divide by tangent of 52 degrees, making sure your calculator is in degree mode. Go ahead and do that. Great, and you're going to get x is about 8.59. X is approximately 8.6 or 8.59, depending on how many significant figures you have or decimals you need to have the answer in. Okay, next problem. Given a right triangle has an opposite length 7 and a hypotenuse length 13, find the angle theta. Okay, again, you got to draw a right triangle. Okay, we have a right triangle. Now, the question is, where's the opposite? Well, we know the hypotenuse is always here. That's equal to 13, okay? There's only one option for that one. The opposite, okay, well, let me think about this. If I make this the opposite, this 7, then the angle would have to be here, okay? So finding that angle there, if you want to label it correctly, okay? Now, I'm talking about opposite and hypotenuse. Hypotenuse and opposite. Oh, that's sine when I'm talking about opposite and hypotenuse. Sine of the angle is equal to, so opposite over hypotenuse, so that's going to be 7 over 13. Okay, now what you need to do is you need to take out your calculator, if you haven't done this before, and do inverse. Theta is equal to inverse sine of 7 over 13. Now, it depends on what your teacher asks, but if you want to get theta in terms of degrees, you better be in degree mode. And that theta is going to be approximately 32.6 degrees. 32.6 degrees. Okay, not radians, degrees. Okay, last problem. Suppose there's a right triangle with opposite length 12 and adjacent length 9. Okay, well, what do we need to do? Well, they're going to tell you in the problem. In the problem, they're going to tell you, find the angle theta. Find the angle theta. And always the first step, draw a triangle and then solve. So draw a right triangle and label what you have and what you need to find. Go ahead and try that in your own. Pause the video. I'll be right back. Okay, so the first thing we need to do is draw a triangle. Okay, and this is a right triangle. Now remember, right triangle is not a triangle that is never wrong. Okay, so what we want to do is we want to label. We don't have hypotenuse, but we have the opposite. This is longer. This base side is longer. I'm going to put 12 there, and I'm going to put 9 here. Okay, now Where is theta? The opposite is 12. Opposite is 12. So the angle is going to be up here because the opposite is 12. Now, think about this. We have O and we have A. Which one out of SOH CAh TOA has O and A? Bingo. TOA. Okay? TOA. So now what we want to do is we want to set up a tangent relationship. Tangent of the angle that we do not know is equal to opposite over adjacent. Okay? And so we're going to have, get out your calculator, and we're going to have theta, therefore, is equal to inverse tangent of what? Of 4 over 3, right? Basically, 4 over 3. Okay? And when we do that, we're going to get theta is equal to approximately 53.1 degrees, okay? Great. Now, if you enjoy this content, so that's the answer. If you enjoy this content, before I ask you if you enjoy this content, if you have questions, let me know in the comments about any math problems you have. I'm here to help. But if you enjoy this content, it's helpful, please like and subscribe, share, and all that good stuff. Share it with your friends and let me know how I can help. Again, my name is Mr. Ray. I'm here to help, and I'll see you in the next video.